than it would be algebra. So they give you a point, and that point is just x, y. They're both positive. So if you need to think of a point to actually kind of like visualize what's going on, let's say we have the point, we'll go with like 3, 2. So here's my point 3, 2. And it doesn't, like whatever you want, it just both of them have to be positive. That's what x and y mean. So what happens to that point, how is it transformed if you make the x negative? Well, that means it becomes negative 3, 2. Where does it go if it becomes negative 3, 2? On the other side. So 1, 2, 3, it now goes on the other side. What is that called? Yeah. Nice job. So you're reflecting over the y-axis when you're making the x value negative. So now that you kind of see how that one is done, if you look at the next one, now it says x negative y. So now we're down here. The x stays the same, but now the y is negative. So what's that called? Dylan?
Reflection over the x-axis.
Yeah. So reflection over the x-axis. All right, the last one says make both of them negative. So now I have a negative 3 and a negative 2. What's that one called? You could call it 2 different things. Eric, you whispering something?
No.
No. Brenton.
Is it like a reflection of the origin?
Yeah. Nice. So you could say it's reflecting over the origin. This guy right here, it's like bumping or hopping right over the origin. You could also say that it's a rotation of 180 degrees. Either one. And that goes back to like, that's a geometry thing when you're rotating 180 degrees. So you're also reflecting over the origin. We'll use reflections in graphs more than we would use rotations of things. Questions? So I was walking around and looking at the homework. It looked pretty good. Was there questions with distance or midpoint formula? Any of those problems? So today we are going to do basic graphs. And I stole this from Mrs. Lucas, which if you had her.
Oh
Yes.
Oh yes!
You probably remember
It's
this.
the most fun part of the year.
This I don't have because I don't have a brother-in-law who makes these fancy things. But we're going to talk about some of these graphs today as a little review. The ones at the top here, we'll be talking about those when we get to trig. So the sine graph, the cosine graph, the tangent, and then the last one here is called the cotangent. But we're going to look at some of the other ones as a review. And I'm going to show you how to graph them without making a t-chart, just like doing some basic mental math. And the goal is then for you to quickly look at an equation and think about the shape within seconds and be able to graph it within seconds. Like quicker in your brain than it would take you to type into the calculator, that kind of thing. No t-charts.
Yes.
So again, these are basic graphs. Once we get out of the basic graphs, we're going to have to make t-charts, but basic graphs. So if you have a line, Brenton, what's the basic form of a line? Uh-oh.
I'm blanking right now. X. Y equals X.
Y equals x. Generally, we place an m in front of that x and a b. And get y equals mx plus b. But yes, the most basic is just y equals x. So the most basic will be y equals x. That's called a parent function. We're going to go a little bit more involved so that we're not like super basic, and we'll just throw a couple extra numbers in here. Why don't we say like 3x minus 2. I used 3 and 2 in the last problem. I'll keep the 3 and 2. Sound like good numbers today. All right, so how do you graph a line? This was like probably the first thing you should have graphed, Colin, right?
Wouldn't the 2 be where the it crosses the lines?
Yep, so y-intercept.
And then isn't 3 slope?
Right, and 3 is the slope. You move with the slope, hence the m. You begin on the y-intercept, or b. So you're starting at -2 on the y-axis. You're moving with the slope. Slope is rise over run. So moving up 3 over 1. Do that a couple times, you got a couple points on your graph. And then we have a line. Y equals mx plus b. Again, that would have been like the first thing that you would have started graphing. Maybe in pre-algebra, definitely in algebra. Okay, so these are going to kind of just build on the existing function. So after the line, back in chapter 4, we did that wonderful parabola. So we took the x, you place a power on it, and it creates a curve. So we got that wonderful U-shaped curve. We're going to talk about a basic one. There's going to be an a in front. That a could just be any number. And then x minus h squared plus k. This was the graphing form. We called it vertex form of a parabola. Does anybody remember what the h and k tell you about the equation?
They move the graph up and down.
Yeah, so it moves the graph up and down. This one moves it actually left or right. And the k is the one that moves it up and down. It also gets us the location of the vertex. Remember, you got that u, the bottom part of the u is called the vertex. And that vertex is h and k. Anybody remember what you have to think about h? Something special we have to remember when we're looking at that number h.
Since there's a negative sign, it would end up being the opposite.
Right, exactly. So because of that negative sign, it's actually the opposite of what you see. So the h is a negative, we're just pulling that h out. So it's the opposite. So I'm going to show you how to graph this without making a t-chart. We're just going to do a simple little graph, and I'm going to continue to use those two numbers. So we'll say x minus 3 squared, and then plus 2. So when you're graphing, the h and the k are the important numbers. There are values in the graph, values in the equation, and that's going to be kind of our focal point. So Garrett, the vertex would be
That'd be 3 positive 2.
3, +2. So right here is the h. It's separate from the minus sign. The minus sign is part of the equation. So it's separate. So I'm going to start at 3, 2. So over 1, 2, 3, up 2. That's the starting point. Now, we're not going to make a t-chart. We're going to do some mental math. And every problem we do or every graph we do is going to be the same thought process. So if I start at this point, my power is a 2. So that means that power has to apply to the x. So if I move over 1, to get y, I have to square x. X is the independent variable. So you find y by doing something with x. 1 squared is 1. That tells you how high you need to move up. So once I have that 3 and 2 plotted, now I'm just thinking about what are we doing, how far are we moving for x. So I'm going to do this again. Go back to the original point, I'm going to move to the right 2. I have to square any x value. 2 squared is 4. That's the amount then that I need to rise. 1, 2, 3, 4. One more time, going back to the point, if I move to the right 3, 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, ooh, at the top, 9. So that is the right side of my parabola. Just doing a little mental math. So once you move to the starting point, then we're squaring the distance that we're going to the right. So we're going to do the same thing on the left side. If you go -1, -1 squared is still 1, -2 squared is 4, and -3 squared is 9. That is called quick basic graphing. So we start at a point, that point is from the numbers in the problem. And then whatever you do to x is based off of the power that is in our function. Questions? So we're going to try that same exact process for the next problem. And I'm going to use the same numbers as well, just so you can see how two numbers can kind of change based off of a graph. So cubic means that we have something that's cubed, kind of going off of here. Where's my cube? Oh, there's no cube down here. Oh man, no cube. Anybody remember what the cube graph looks like?
Does it look like this?
Yeah, it does look like that. Why isn't that on there?
It was, I thought it was.
Yeah, we
last year.
did it last year.
Yeah,
Yeah, we did a whole dance.
We did a whole
Did the
dance.
dance?
Yeah.
So I don't know why that isn't on there, but the cube graph looks like this. So one half goes up, the other half goes down. Whereas the parabola goes both. This one is kind of opposite, like a little. It is Egyptian girls, the dancers. Yeah. So this still has an H and a K, but instead that's our middle point. That's the middle of the graph. So wherever the center of the graph is, where the one half goes up and the other half goes down. So if I use the same exact numbers from above, it was x minus 3, now it's cubed, and then plus 2. Is that what we had? Yeah, I want to make sure we got the same one. So that 3 and 2 are going to become the middle of the graph this time instead of being the lower point. So go into 3, 2. Then we're going to apply the same exact thought process, but we're cubing x. So if I go to the right, I'm moving one space to the right. 1 cubed is 1. What's 2 cubed? 8. So when you move right 2, now I need to go up 8. And if I connect those 2 points, actually 3 points, I have that top half of the curve. What happens when you cube -1? It's negative. So -1 cubed is -1. I'm cubing the -1 because we're on the left. And when you move left, it's negative. And then -2 cubed is -8. That's how you get the part that goes down, because when you're cubing a negative number, it stays negative. And if you connect those, and now I have that graph that curves. Questions? So now we've seen the line, and based off of that power of 1, we made it squared to start giving us a curve. Both sides go up because you're squaring it. It makes everything positive. When it's cubed, one side goes up, the other side goes up. So if you flip it over, I think there are 3 more graphs over there. So we got an absolute value graph, which is on here. Yeah, both sides go up. Keeping the equation the same, we're just changing what we're doing with x. So now I have absolute value bars around x. The h and the k in the problem, this goes back to vertex. So it has a vertex. The vertex is always the lowest one. So if I use the numbers again, x minus 3 with absolute values and then plus 2. So every one of these graphs are still going to begin at that 3, 2. Remember, this is supposed to be a V this time. So using the same thought process, if I move over 1, the absolute value of 1 is? What's the absolute value of 2 if I move to the right 2? 2. The absolute value of 3 is 3. And I can see that they're trying to, like, they're just continuing in that same linear format, which is how we get a line. There's the 1/2. Do the same thing to the other side. So absolute value. If I move left 1, the absolute value of -1 is still positive. Absolute value makes a number positive. left 2. Absolute value of negative 2 is 2. Absolute value of negative 3 is 3. So the key thing is where it begins and what are you doing to x. So you need a starting point and you need to understand what the function is doing. Is it squared? Is it cubed? Is it absolute value? Questions? So I think we have a square root and a cube root left. Yeah. So now we have a square root. So the function always affects x because x is the independent variable. So now I have a square root that's with x instead of a cube, or instead of the absolute value, instead of the square. Same exact numbers, just change the symbol. So we still have that 3, 2. We're going to see what that 3, 2 does for the problem. Over 3, up 2. So same thought process. If I move to the right 1, I'm now taking the square root, because this is what my symbol says. It says square root. So right 1, what's the square root of 1?
1.
Now, if you have to take the square root, how far do you want to move to the right so that we can get a nice square root? 4. So if I go to the right 4, the square root of 4 is 2. And that tells me I would want to move up 2 spots. So instead of moving to the right 2, the square root of 2 is 1.4, and I don't want to use a decimal. So I moved right 4 so that I could get a nice square root. Alright, so here's this side. Here's our little dancing guy over here. The square root only goes one direction, because can you take the square root of a negative number?
Nope.
No. So it just starts here at those 2 numbers, and it continues in the positive direction because negative square root doesn't work. Questions? So why don't you see if you can think about the last one that's on there. A cube root means we have a little cube with the radical. And again, those same numbers, x minus 3 plus 2. So we know 3 and 2 have to be where we're focusing our graph. So try and see, how does that apply with x? A little bit of mental math. I'm taking the cube root. Dylan, what's the cube root of 1? 1. So if I go right 1, I go up 1. What would be the next number we could take the cube root of? 8. So we would go right 8, which has to be 1 off. And Dylan, the cube root of 8 is 2. So that tells me to vertically move up 2. So here's this side of the graph. Dylan, can you take the cube root of negative numbers? Yes. So the cube root of negative 1 is negative 1. If I use 8 on the positive side, I probably can use negative 8 on the other side. So if I go over negative 8, the cube root of negative 8 is negative 2. So I would move down 2. So starting in the center, I'm now connecting in the opposite direction. So my first graph for the cube was kind of going up, and now this one is kind of moving to the side more. It's stretching out horizontally instead of it moving up vertically. All year, we will do these graphs, and they will kind of sprinkle back in at times. I know in chapter 1 we go over them again because it's really important to kind of look at a graph or look at an equation and know what the graph looks like. The goal is for you to see an equation and to quickly know or recognize the shape of the graph. So if it has a cube, it needs to kind of stretch out horizontally so that you can quickly work on that part and focus on the new concepts. Questions? I think there's just one other thing down there, just kind of tips for graphing with the calculator. When you're graphing on the calculator, you want to get it into y equals form. So any equation when you're graphing on the calculator has to be in y equals. And then the other one would always be, I'm going to cross off 3. You would want to check to make sure that your window fits the graph. So you want to make sure that the important parts of the graph should be in that calculator viewing window. Underneath there, it talks about the Zoom standard. And that's, does it say that or no? No Zoom standard. Okay, well, I must have got that part off. Zoom standard is the regular screen that when you use your calculator, it's always going to be in, and that uses the -10 and the +10 values. Questions? So, in your packet, the other packet, the homework packet, there is a basic graphs worksheet, no calculator. So try and think, like, where's the starting value? And then how does the exponent, the absolute value, the radical affect the graph? The bottom one, I believe you'll have to use a calculator for, I think that last one. So you have 10 minutes, 9 minutes. Use this time to either, you can ask questions about the important concepts worksheet. I'll walk around and answer questions that you have. Or if you have that done, no questions to ask, use this time then to work on the worksheet that's in the packet. Questions? Anybody have problems so far with Google Classroom? I know a lot of people have signed up. If you are on PowerSchool and you do Google Classroom already, that it's already entered into PowerSchool, so I have that updated already. If you haven't done Google Classroom yet, check your email, your student Gmail account from me. There should be an email saying to log into Google Classroom, and then the student survey is the first thing that you should see under classwork. Sign up for Remind. Last night I sent the answers to this worksheet through Remind that you have for tonight, and I also posted it to Google Classroom. So check those answers. Today's worksheet is on there, yesterday's worksheet, and then tomorrow's. So I have the 3 answer sheets posted to Remind in Google Classroom, so make sure you're checking